Start. Good afternoon. Thanks everybody for coming. My name is Luke Daley. This is Peter. We're here to talk about Spock and Geb in the realm of functional testing. So Peter.
Yeah, good afternoon everyone. Great to see so many of you here. My name is Peter Niederwieser. I'm an engineer for Gradle, the company behind the Gradle build tool. I'm also a computer language and chocolate addict. I'm based in Linz, Austria, and I'm also the creator of the Spock testing framework.
And I'm the other half of the technology stack we're looking at, creator of the Geb framework. My name is Luke. I work at Gradle like Peter, and originally based from Australia.
Okay, so let's get started. What's the challenge in functional web testing? All of you who've tried to do some automated functional web testing probably know that it's really hard. It's hard to automate this kind of tests. It's easy to get flaky tests that pass half of the time, fail the other half of the time. And functional web testing, these tests can be really slow to run. So there are a lot of challenges involved in doing automated functional web testing. But on the other hand, it's also very rewarding because if you have automated functional web tests, this really proves that your app works. If you don't have such tests, it's very hard for you to prove that your app really works. Also, it allows you to iterate faster because it's very easy to rerun these tests whenever you've made some change to your app. And being able to ship a higher quality product and being able to iterate faster, that boils down to saving real money. So what are the different approaches that you could take towards functional web testing? And I'll quickly go through some of the approaches. So the classical, probably the oldest approach is what I call the recorder-driven approach. And what this is about is that you have a human sitting in front of the browser, driving your web app, and you simply record that. You have a tool that records the human's interaction with the browser. And then whenever you want to test that interaction, you just replay that recorded interaction. One example for that style of functional web testing would be Selenium IDE. And what's great about this is that it's really easy to produce this kind of test, right? You just sit in front of your web app, you click through your web app, you drive it through the browser, and you have that tool that records it. So that's great. On the other hand, you don't really have a textual representation for your test. All you get is that recording, and that means that it's really hard to reason about that test. If you need to, these kind of tests, if you need to quickly answer the question, what does this test do? The best you can probably do is to rerun it and watch the recording. Also, these tests are really hard to maintain and evolve, and since maintenance and evolving functional web tests is the challenge in functional web testing, this approach has gone out of fashion over the years. Another approach that you could take is what I call the scripting approach. And this is about scripting the browser interaction. So you now have an API that lets you drive the browser programmatically. Examples for that would be, for example, GNU Web Test or what I call the early WebDriver. The cool thing about that is now you have a textual representation, a program that drives your web browser, and that means it's much easier to reason about this style of tests. It's easier to maintain them and evolve them compared to the recorder-driven approach. Now, I'm not saying that it's easy to do it, but at least you now get a fair chance to maintain and evolve your tests. On the other hand, this kind of test is really low level and uses a HTML-centric language. So if you read a test that uses this approach, it's a lot about selecting content of your web page, clicking a link, clicking a button, and not really about the use cases of your application. This approach allows for some reuse and abstraction, but it's limited. Yet another approach is what I call the model-driven approach. So again, you have a programmatic API, you script the interaction, but not so much with your browser, but more with the model of your web app. So you write a little model, some code that models your web app, and then you program your tests against that model. An example for that would be WebDriver with page objects. And Luke will talk more about page objects later. The cool thing about it, it's easier to reason about and maintain and evolve than the scripting approach. It's about as good as it gets. Another advantage is that it uses a high-level domain-centric language. So when you look at a test that uses a model-driven approach, you will read something like, put an item into the shopping cart, go to the checkout page, enter credit card details, rather than selecting this content, clicking that link. So it's a much more high-level approach. It also supports great reuse and abstraction. And if there is one drawback compared to the scripting approach, then perhaps is that the initial cost to get started with the model-driven approach is higher, because you have to know how you write that model of your web app and how you maintain it. In the last few years, another approach has come very much in fashion, which I call the natural language approach. And what I mean by that is that you write tests, or you could also call them use cases, in an English-like language. Probably most of you will know Cucumber, which is one of the most famous frameworks in the natural language section. Another one would be JBehave. And really, these frameworks, they can't just be used for functional web testing, but for any kind of end-to-end testing. So what you have there is another layer on top of the scripting approach or the model-driven approach, where you write your tests or use cases in an English-like language that gets then mapped to the lower scripting or model-driven layer. The great thing about that approach is that since the tests are ultimately written in an English-like language, there's a much greater chance that you can involve non-technical stakeholders, because you no longer have things like a class declaration or a method declaration. You just have this kind of English-like or natural language-like language. It does support reuse, but there's one big challenge with that approach, that you have to map that English-like language onto the lower levels that really do the automation. So there's an additional cost in maintaining that mapping, and then that can be a challenge when your test suite gets larger and more complicated. Now, how do Spock and Geb fit in here? We like to think of this as yet another approach of functional web testing, and we call it a developer-focused approach. What I mean by that is that with Spock and Geb, you only write code. In our case, Groovy code. So there's no natural language syntax or something like that. It's all Groovy code. But still, we think that the tests that you can end up with are very readable. And hopefully we'll see that in some of our examples. Because we exploit the Groovy language and its DSL features to give you a language that's really code, but also very readable. Geb also comes with very strong modeling, even stronger modeling than what you get with WebDriver out of the box. So it's definitely a flavor of the model-driven approach. And both Spock and Geb focus on usability and providing good feedback. So we really try to give you a full solution for testing, and we try to give you early feedback if something goes wrong, and give you really good feedback so that you know what you'll have to fix. Okay, so now let's dig in a bit deeper, and let's talk about 3 building blocks for the solution that we propose. And these building blocks are WebDriver, Spock, and Geb. So a few words on WebDriver. At its core, WebDriver is an API for browser interaction. It's also known as Selenium 2. That's the same thing. It's an extremely active project. A lot of big players are involved: Facebook, Google, Mozilla, and so on. And it's really heavily used by big sites. And that's a good thing, because WebDriver is really the working horse. So whenever you have a Spock Geb test that drives your browser, ultimately it's WebDriver who does the interaction with all the browser, presents a consistent API for you or for Geb to use. So WebDriver is really the workhorse here. And I'd say it's one of the best technical solutions to browser automation. Okay, let me do a demo on that. Just to give you an idea, since Geb and Spock, Geb is based on WebDriver, how would a pure WebDriver test look like? So we'll have a quick look at a WebDriver JUnit test. So this is not yet using Spock. It's using plain JUnit, and probably most of you will be familiar with JUnit. So we have our test class, and this test class has a driver. That's how we interact with WebDriver. We have this driver class, and in this case, we chose to use Chrome. So we instantiate a Chrome driver. We just do that once for the whole test class, because perhaps we want to reuse the same browser to speed up our tests a little bit. And after all the tests are finished, we quit the browser. So that would be the before class and after class part here. And then we have a single test method here where we check whether we can log into our application. That's kind of the easiest thing, most basic things to test. And here we use the WebDriver API directly. So first of all, we navigate to our login page. And then we have the first assertion. We select some content on the page, namely the text of the heading, and check whether we are really on the sign-in page, whether that heading says, please sign in. And if that's the case, then we continue. We again use the WebDriver API. And I won't focus on the details of that, but just so that you get the basic idea. We enter a username and a password. In our case, both of them are Devox. So we again drive our application. We click a button. And then we have a second assertion. And here we check whether whether the heading now changed to login successful. So whether our heading with these credentials was successful. So that's a basic flow for a very simple JUnit WebDriver test. So now let's bring in Spock. So a quick show of hands, who of you has ever heard of Spock before? Oh, lots of hands, who's used it before? Couple of hands. We'll have to work on that. Okay, so what is Spock? Spock is a developer testing framework, specifically designed to be a great solution for testing Java and Groovy applications. Now, when you use it for web functional testing, of course, it doesn't matter in which language your web application is written in, but Spock is very versatile. You can use it for unit testing, integration testing, functional testing, and when you use it for unit or integration testing, it best works for Java and Groovy applications. Of course, it's open source, Apache license. Its missions are to give you a tool that allows you to write really expressive tests that are a lot of fun to read and write. It has strong JUnit integration. That's very important to integrate with all the IDEs and build tools and CI servers. Many people think that Spock is just a DSL on top of JUnit, but actually it's a full-blown testing framework. The JUnit integration is mainly so that we can steal all the great tool integration that JUnit has. That's the main reason for our strong JUnit integration. And it's used by quite a lot of projects and companies. So I've listed a few of them, like Gradle. We use Spock for all our tests. Some Spring projects use Spock, Tapestry and Grails, the web frameworks, and some companies like Sky UK, JFrog, Sony, Netflix, and many others. Now let me show you how the same WebDriver test would look like with Spock. So now we're using Spock and WebDriver, but we are not yet using Geb. So let's have a look at this one. For those of you who haven't seen Spock before, this is how it would look like. It's written in Groovy, but for Spock tests are always written in Groovy, but for Java people, it's usually very easy to pick up. Groovy is very easy to pick up. As you can see, the syntax is very similar to Java. Actually, most valid Java syntax is also valid Groovy syntax. Spock specification, we prefer to call it specification rather than test, is structured very similar to a JUnit test. So you have a test class in Spock's case that extends from the specification class. So each test class extends from specification. You can have fields, you can have fixture methods, like this one, the cleanup spec would run once after the test class, so that's the same as JUnit's add after class. So again, here we quit our browser. And then you have the test methods. And here's already one difference in that you can use a string, a full sentence to spell out the name of your test method. That's really nice because it gets you closer to writing specifications that you can read as requirements rather than test methods. So that's a nice little thing that you can use strings as your method names. Another big difference is compared to JUnit is that a test method in Spock is structured into multiple segments. You see here we have a when, a then, another when, and another then. And these, we call them blocks, and these really have meaning to Spock. For example, in the when block, this is where you exercise your code. So in this case, this is where we drive the browser. All driving of the browser goes into the when block. The then block, this is where you put your assertions. So Spock knows everything in here is an assertion. So that's why you don't have to say assert here. That's a Boolean expression, but since it appears in the then block, Spock will automatically treat it as an assertion. So again, what are we doing here? We are logging into our page using the plain WebDriver API, and then we have the first assertion. And in Spock assertions, there's no assert equals, no assertion API in Spock. Instead, it's all just plain Boolean expressions. So again, we get that heading and check that the text equals please sign in. And then it's the same as in the JUnit example. We use WebDriver API to fill in the login credentials. We click the button and check whether the heading changes to login successful. Now let's try to run this one. So the Chrome driver is really quick. This is our app, but you don't see much because the Chrome driver is really fast. And you can see, since we integrate with JUnit to IntelliJ, that's just a JUnit test. You get the usual output. You see here, you have the full strings here, can log in successfully. That's a method name. We have a second test here, navigate to a secret page. Now let's try to make the assertion fail. Because the big question, of course, is if assertions are just Boolean expressions, what kind of output feedback do you get when the test fails, right? So let's try that. And this is the kind of output that you get by default when you write a Boolean expression and it develops to false. So here is your assertion, your Boolean expression. And then what Spock gives you, it shows you the value of each sub-expression. So these ones are probably not so interesting, but interesting is the text. The actual text was please sign in. And we expected that text to be please sign out. And actually they are not the same, false. Spock goes a little bit further. It automatically understands that you are comparing two strings here. You don't tell it, but Spock understands it. So it will say, actually, between these two strings, there are 3 differences, 80% similarity. And it goes a little bit further. Whenever you have an equals comparison that fails, you get a diff view, both in IntelliJ and in Eclipse. So you can see we expected please sign out, but we got please sign in. And if you're comparing 2 larger bodies of text, the diff view really helps. And it not only works for comparing strings, but comparing any objects. No matter which objects you compare with an equals, Spock will try to render such a diff view that makes it easy for you to understand why those 2 objects are not equal. So that's the kind of thing you get out of the box. And you can write arbitrary Boolean expressions, and you will get that kind of output. Now, in functional testing, in functional web testing, often you don't have these isolated methods as you have in isolated tests as you have in unit testing. Instead, often you want to test the whole workflow, a workflow composed of multiple steps. For example, in this case, the first step in my workflow is to log in. And then I have a second step, which is I want to navigate to a secret page. And I can only do that after I logged in. Now, if you would have to write up that workflow in one large method, it could be composed of many steps, and it could become bothersome to read if it would have to go all into one method. And one feature Spock provides there is that you can write the test for a workflow and have one method for each step. So we have 2 steps, 2 methods, and we annotate the whole thing with add stepwise. And this tells Spock that this is a workflow composed of multiple steps, and it should run all the methods in their declared order. And as soon as one of them fails, it won't bother running the remaining ones. Because if I can't log in, then it probably doesn't make sense to navigate to the secret page. It would just be a consecutive error, would give me lots of reds on the CI server, but really I would probably only have one problem, namely that the login didn't succeed. So you can see here, the login didn't succeed, and the second test was just skipped. Likewise, Spock knows that the first step is a prerequisite for the second step. So if I run just the second step, Spock should nevertheless run the first one as well, because it knows it's a prerequisite. So a few nice things you get, especially for functional testing, by using this stepwise style. Okay, let's do a very quick Spock feature tour just to give you an idea of what other things you can do with Spock. Another neat thing about Spock is data-driven testing, and this is about running the same test multiple times but varying the data. So for example, in the login case, I could try multiple logins but vary the username and the password. And the way you do that is with a where block. So that's where the data-driven comes in. And this is a data table where the first line is the header. So we have 3 variables here, username, password, and target page. And then each other line provides 1 value. So this test would be run twice. First, we would use, for the first run, we would use a username of Devox and a password of Devox, and we would expect to land on that page. And for the second run, we would use a different password and would expect to land on the login failed page. So that's a nice way to run the same test multiple times and just change the data. Another feature is Stubbing and Mocking. So Spock comes with a built-in mocking framework, but I won't talk about it here because it's not really relevant for functional web testing. But it's good to know that there is a neat mocking framework built into Spock. Last but not least, Spock comes with a number of extensions, and there are also a number of third-party extensions, and they are mostly about integrating with other frameworks and platforms. So I've listed some of the other frameworks that we integrate with, Hamcrest and Unitils, JUnit extensions, I would say. Then we integrate with the Spring test context framework. We integrate with the Juice and Tapestry IOC containers, with the Grails web framework, with the Groovy desktop application framework, with Aquilian if you want to do in-container J2E testing, and a couple of others. Okay, with that, let's get to our third ingredient, which is Geb. So what is Geb? Geb is a Groovy browser automation framework that's built on top of WebDriver. So the heavy lifting of actually interacting with the browser is done by WebDriver, and Geb provides a really nice API and full stack solution on top of WebDriver. It's also open source, also Apache license. Also, if you write the Geb test, you write it in Groovy. Same as for Spock, Geb is very developer focused. It doesn't work only with Spock. You can use it with any test framework you like. But we think it works particularly well together with Spock, partly because they have a very similar philosophy. And Geb provides solutions to common problems that you face in functional web testing that WebDriver doesn't provide out of the box. It's also used by quite a lot of companies. We've listed some of them here: Sky UK, Yellow Pages in Australia, Comcast, and others. Okay, now let's have a look at what a Geb and Spock test for the same thing would look like. So again, it's about logging into our web page. And the functionality is exactly the same as the previous one, but you can already see that it's a lot less code and a lot cleaner, and hopefully much more readable. So again, in this case, for a Geb test, we don't extend the specification class, but the Geb spec class. We have our test method. And now you see with the Geb API, it becomes much easier to navigate to some page. So we navigate to some relative UL here, relative to the base of our application that we have configured elsewhere. And then we just say, go to the login page. Then selecting content, like the text of that heading, is really easy. And Luke will talk more about that. Also filling in forms, you see, it's so easy. You just set username, password, and even non-technical people will be able, if they are willing to look at this code, they will be able to kind of get what's going on. They might not be able to author that, but we think that they will be able to get what this test is about. And then finally, we select some more text and check that we ended up at that login successful page. So that's what a simple Geb spec test would look like. And if I run it, of course, it will behave just the same as the WebDriver example, but it's much easier to write, nicer to read, and to maintain. Okay, and with that, I'll hand it over to Luke, who will tell you more about Geb.
Thanks, Peter. So just to go into some of the details here of what's going on, we'll explore some of the Geb API. At the heart of the API is the browser object, geb.browser. And this wraps the WebDriver object and a bunch of other things, provides a kind of a whole lifecycle management. So we saw the go method a second ago, passed it a URL, and we'll go into that URL, it was actually calling browser.go behind the scenes. And this dollar method, which we were passing a selector to, which we'll come back to grab content out, it's going via this browser object. So it's really the center of the API. And in a Geb spec or in other situations where you might be using Geb, that's just implicitly delegated to. So you very rarely see browser.go or browser.dollar just go, and it all kind of works. That's one of the things you get with the Geb Spock integration. So the Navigator API, so you might be this dollar floating around here. If any of you have been doing any front-end development working with jQuery, this is probably going to be pretty familiar. So this is what we call a Navigator API. It's inspired by jQuery. It isn't jQuery. It's not 100% API compatible. But when I first came across jQuery, I was very impressed with how powerful it is and how easy it is to get to exactly what I need to get to on a page. And I thought, well, this is exactly the same problem that I often face testing applications where I don't have full control of the markup, or for some reason I just can't get there with a nice, clean expression. So the dollar method returns the Navigator object, and this is the analog to the jQuery object. It represents 0 or more things that I've selected. And also, like the jQuery object, it is always a collection, even though it contains one thing. I can treat it as one thing or as a collection. The general format of this method is I can take 3 things, all optional. I can take a CSS selector, I can take an index or range, and then what we call attribute or text matches. So we have a look at the first one. This effectively is saying I want all the divs on the page, all the elements whose tag name is div. I can use an index here and say, well, I really actually just want the first one. Or I can use a nice feature of Groovy, a Groovy range, to specify I want the first 3. And I can bring them all together here. So this is saying that I'm asking for the third H2 whose ID is section and the content is Geb of that H2. So I can use the different aspects of that method that I need to grab out some particular content. Now ideally, or hopefully, you can get as much as you need via CSS3 selectors. So CSS3 is an amazingly powerful query language, really, or a content selection language. And the benefit of doing something like this is that browsers these days are insanely fast at dealing with these complicated expressions. So hopefully you can craft some CSS selector to talk about the exact content that you want. But if you can't, there are other options as well. So the attribute and text matching, the syntax here may look a little bit foreign if you're not used to Groovy, but this is Groovy's named parameter syntax. It's really just a literal map, really. So here we're saying I want all the div elements that have a foo attribute with a value of bar. The next one is saying that text is a special attribute, which means the actual element text. So this is how I can pull out all the divs who actually have text there. And I can use regular expressions with those as well if I want to do some kind of partial match. Geb supplies a bunch of predicates that I can use. So if I want to grab the paragraph, all the paragraphs whose text starts with the letter P, I can use the starts with, contains, ends with. There are case and sensitive variants. I can use regular expressions with these guys. It's very useful for grabbing a content where you can't get to it cleanly with the CSS selector or something like that. And like jQuery, we can actually jump around content relatively. So this is often the case in a legacy application with bad selectors or things like that you can't directly navigate to what you want to get to. But you can navigate directly to something that's close and then kind of jump around it to get to there. So Geb supports this kind of relative API, and it works exactly the same way that jQuery does. Each method returns another navigator, which is then that content. And I can filter and do all the kinds of things that you would expect to do on these. We also, as Peter showed, provide some handy shortcuts for dealing with form elements, because that's still a lot of what our web applications are doing, is accepting input from the users. So try and make that as short and concise as possible. So when we see this username equals some value, what that's really saying is grab the first thing on the page with a name attribute of that value. So with a name of username, and then go and set its value. So a lot of the times, that's all I need to do to actually find the control I want to set and set it. And if I'm on a page where I have multiple controls and I might have clashing names, I can scope that down a bit. So here I'm saying that grab the login form, the form with class login, and just inside that guy, inside that particular form, find the control with name username and set that value. So if I have multiple controls on a page with clashing names, I can still scope it in. It's still nice. Different kinds of controls are also handled. So select elements, I can just assign one of the values in the select. That can either be the actual display text or the actual option value. I can do it that way. For a multi-select, I can just assign an array. This guy here is just Groovy's, actually that's a list, that's Groovy's list literal syntax. For a checkbox, I can assign true or false to check it or uncheck it, or assign the value, whatever you like to do. And for a radio group, I just set what I want there as well. So I don't have to deal with different APIs for different kinds of controls. It just works kind of intuitively. And it's the same for reading. I can read the value of some select just by asking for that property, and I get the string value that it says is there as well. Okay, so that was the basics of the Navigator API, and that's really at the heart of how you interact with a page in Geb, how you get content out of it. So selecting some content to look at or pushing content in terms of form input. But Peter mentioned that one of the biggest innovations to happen in this field in a while, which was really a few years ago, was to introduce this concept of page objects. And page objects are really just a useful way of thinking about providing some abstraction around the code that we use to test these applications. So modeling the things in the applications and modeling the interactions. In some ways, it's a bit of an unfortunate name because there's much more to it than just pages. But it's kind of the central unit, the thing to kind of rally around. And WebDriver really popularized this kind of idea. WebDriver has its own implementation of page objects, and you can read about that on their website. Geb takes a slightly different approach. So the fundamental tenet here is that having this kind of code in your test is fundamentally a bad idea for a few reasons. One, you're leaking page structure into your test. And two, any kind of real application that's going to be doing a login, that's going to happen more than once. So this was, and what Peter was saying, this is in the early kind of scripting styles, this kind of copy-paste based model was used for this kind of code. So we take that and we basically put any behavior behind a method on an object. And that object, being the page or a fragment thereof, represents what the user is interacting with. So we model that aspect of it. It allows us to encapsulate the structure. This login method now just accepts the inputs. The actual page structure and how that's pushed into the form is encapsulated behind that method. It allows us to have different behaviors, so composite functions can be represented as one particular method inside a page. And of course, these are now reusable. I can reuse them across different tests. So that's the basic idea. Also gives us a mechanism to put higher abstractions into our tests. So if we have these page objects floating around with named content and methods, we can use those in our test to have the actual meaning of the test and what's going on lifted up. So in this first line, contact details form.submit button.click, that's kind of the way the user would think about working with the application. I'm on the contact details form, I want to go to the submit button, I click it. So if I read that, I very quickly understand what's happening. The second one is slightly more subtle in its relevance in that we can start to lift the domain terms of our application up into our tests. So instead of seeing in our test a selector that's getting into some row in a table and having to then match that with the HTML and see what is that actual thing, I can look at this and say, yes, it's actually testing what the price is of the third line item of the first order. So it makes much more sense to me. And as somebody reading the test, that's actually what I care about, not the HTML structure. So how does Geb implement this? Well, Geb has a very strong concept of a page object and a lot of support for modeling this, and this is really one of its strengths. So a page object extends from geb.page, in this base class, and a few static properties that are used. And it's a DSL-based approach as opposed to WebDriver's annotation-based approach, which is very static. So there are a couple of things we can have there, and this does become an object that is floating around. So I can have instance state, I can have instance methods, these kind of things. We'll see what these static properties are about. So the first one, static URL is about the navigation. If I say go to this page, where should I go? So we define a static URL property. Anything that resolves to a string can be used there. And then in my test, I just say to, then the name of that page class. In Groovy, we don't need .class on the end to talk about a class literal. But that's in Java, we'd have to Google homepage.class here. So to is just a method on the browser object. And of course, this URL can be relative as well. If it's relative, Geb's configuration mechanism will work out what's the actual absolute URL for that. And the browser has a page. So I mentioned that the browser is at the heart of the API. It's tracking a page over time. So if I say go to a page, here, go to the login page, its page object is now an instance of login page. So I've created an instance of that, and that's being tracked over time. That's how I can then go page.login and call that method. That method, login, may go and do another action and set the page to be something else. So after that point, it's changed. So we've got browser.page there. The browser dynamically delegates to the page. So we see in this next example, I have browser.login instead of browser.page.login, using Groovy's dynamism here to just dynamically forward that method call on. So any method call that the browser receives that it doesn't know about, it will just say, page, please take care of that. And of course, in a test or a spec, we have dynamic delegation to the browser object. So I can just write login, that's going via the browser to the page. It allows me to just remove a lot of boilerplate from my actual code. So that was the to side of things that take me to this page. But a very important part of any kind of test in this space, and something that I don't see enough of, is checking, after I perform some action, did I get to the place where I expected? Before I start grabbing content off the page and making some assertions, did I get to the right kind of place? So Geb builds this right into the system in terms of the at checking. So for any particular page, I can define a Groovy closure, similar to a lambda or function. Here, this at guy here, which is just a series of assertions that must return a true value for this to be considered, for Geb to consider it being at this page. So after I perform some action, in this case we've got on the menu, we're finding the login button and we're clicking it, we're saying, did we get to the login page after this? And that means, is the title login page? Does the H1 have this value? The whole idea here is to fail fast. So instead of getting some obscure message because I tried to get some value off the page and it wasn't what I expected, I'll get a message saying that, hey, you're at the wrong page. The content DSL is the third part of those static properties. So the content DSL allows me to name and define content within my page using a dynamic DSL approach rather than annotations. So the general form is that static content equals a Groovy closure. Inside there I use the content DSL. I name some content. There are some options I can use in its definition, and then some statement which defines what that is. So here I have some page, and the only thing it defines is the heading is H1. From that point on, I can just refer to heading instead of $H1 to actually get that thing out. It will understand that. So in this case, I simply do heading and it's going to pull that guy out. I can parameterize that to make it more like a template. So now list item is a kind of factory for getting list items out, and we're going to do this via index. So here we call list item 3. The 3 ends up being this parameter to the Groovy closure. So then I'm pulling out the list item using the variant of the dollar method that accepts an index. So I'm getting actually the fourth list item that way. So it's a very powerful way to reuse content definitions by parameterizing them. I don't need an extra definition for the first, second, third, fourth list item. I have some kind of factory to do that for me. And importantly, content can stack on top of itself. So one of the traditional problems with, say, the annotation-based approach is that you end up with very long selectors. So if I want to get to some specific part in the page, I have a long selector, whether it's XPath or CSS, to try and target that guy. And if something in there breaks, if that moves around the page and I have to reevaluate that entire selector, work out what it is. But if we break each part down into different parts, then we're a little bit isolated from that problem. So if we look at this case, here we're trying to model the Google results page and the links on that. So I have the first result link is actually what I'm interested in. It's defined in terms of, okay, it's the result link at index 0. Result link is defined as all of the anchor tags with the class of L at a particular index, and so forth. So I can just stack content definitions on top of each other. If the actual list item that all the results are listed in on the Google homepage changes, I simply come in here, change this, and if the relative structure inside is still the same, everything still works. That's the idea here. Isolating things down the line from changes up the line. And the content defined doesn't have to be a value. And sorry, it doesn't have to be a navigator. All the examples we've seen so far, we've been returning elements on the page, but I can actually just return simple values. So in this case, I'm defining heading text to be the text of H1. So I can just refer to that guy. Similarly for doubles, like whatever type of value object I want to use in there, and then reading that out, that's what I get. And if for any content that is defined, if it is not something that is deemed to be true, then we'll get a fail fast. So if I try to grab some content on the page, but there was nothing that matched that selector, in this case, I'm asking for H1, and let's say there were no H1s on the page. If I try and access that content, I'm going to get an exception. Geb's going to say, you asked for the H1, but I couldn't find it. And similarly, if to turn that off, I can just say this thing is not required. Sometimes it might be there, sometimes it's not. I might want to assert that it's not there, for example. Okay, so let's have a look at that. So here is the same kind of login case written with Geb page objects. So say when I go to the login page, then the heading should be please sign in, and just for some extra fun, I'm counting the text controls on the page for something to do. Then if I fill out the form with a bad password, then I get to the login failed page. So you can see here that it starts to become a higher order, higher level of abstraction in the actual test itself, and reasonably simple for somebody to read without having to understand the structure of the page or what's actually going on. I can get a good feel for what this test is doing. And I don't have to do any mapping between a natural language and the actual implementation underneath. This is all just code that I can click around and navigate to my IDE and that kind of thing. So let's just quickly change this to say, let's make this fail and say if I log in, then for some reason I expect to be back at the login page instead of the login failed page. And I get an assertion inside login pages @check saying that that actually failed. So it's checking, are we at the login page? Well, no, we're not, because the title was login result instead of sign-in page. So just a couple of things on pages here. So my login page is defined in terms of, here's my URL /login. When I say please go to the login page, Geb's going to use its configuration mechanism to work out what is the actual URL to go to there. I have my @check. Here's my content I've defined. There's the form. It's the only form on the page. My heading, sign-in buttons, etc. And here's my login method, and any behavior like that can be implemented just as a plain method on the class. There's no magic there. Inside, I can use all the defined content. Geb will just work that out and return those values. Now, you might have noticed if you're used to IDEA, you're saying that that underlining there is saying that IDEA doesn't know what that guy is. This is Groovy code. It's very dynamic. If you're more into the static typing type of thing, you can use Geb with a slightly different style. It's slightly more verbose. We have to track a few things ourselves, but that gives the IDE much more understanding of what's going on. So we can get better auto-completion, better navigability, that kind of thing. So we're taking a bit of a hit in terms of readability, but we're getting better tool support if we use a slightly different style with Geb. So if you're not so comfortable with dynamic languages, it's still got you covered there. All right, so async, this is the really hot topic in trying to functionally test apps these days. So modern web apps are hugely asynchronous. Lots of AJAX going on, lots of effects. Anytime you have an effect, you now have asynchronicity in your application. You can't ask for that text and still it's finished animating in. Single page apps are just riddled with asynchronicity by nature. And this is a really hard problem to solve categorically. The only known solution to this problem is to use what's called a spin assert. And a spin assert is where we just literally keep trying something for a certain amount of time, keep waiting for something to be true, and we time out if we've waited for too long. And Geb has support for this. So in this case, we're sending a request, some kind of asynchronous AJAX request. Clicking that, then we're going to wait for the spinner to be displayed. So we use this wait for clause, pass in a Groovy closure. So this function, this bit of code is going to be run until it returns something that is true. So wait for the spinner to be displayed. And then we're going to wait for the paragraph with class request result to have certain text. So you can do a similar kind of thing in WebDriver. What's nice about this is that Groovy's closure syntax makes it much more concise. You don't have the blowout of the anonymous inner class syntax. It's also a much more powerful mechanism due to the more relaxed typing going on. And I can have multiple clauses in here. Inside a wait for, every single expression is treated as an implicit assertion, just like in the Spock then block. So I can wait for multiple clauses to be true. So that's very good for in your test sort of doing ad hoc waiting, but I can also define in my page, my content DSL, that this particular bit of content may not be there just yet. So if I ask for it, just behind the scenes, wait a little bit, do the spinning, and then when it gets there, return it back to me. So I can get the fact that this is asynchronous and may not be there yet out of my tests and down into the page objects, which is implementation detail. This is really the kind of best way to do it. You don't really want to see a bunch of wait fors in your test, because that's not how a user thinks when they're actually using your application. They're just clicking buttons and happily doing things and not really thinking about the fact that they're waiting, hopefully. So we have the same case we've been going through so far. It's a login, but instead of being a synchronous login now, I try and log in, I get a spinner, I get some kind of thing telling me if it worked or not. If it works, I get a message saying it works, and then I get redirected to another page. So lots of asynchronicity there. So to make that work in Geb, this is how I would do it. So this looks very similar to our previous test. And notice that there, apart from the word async in here and this, which I'll get back to in a second, we actually don't have the fact that there was asynchronous behavior going on in the test. That's very important. So as async login page, when we do a login, then alert message and alert dialog have these values. Go to async login page, saying alert message is implicitly asynchronous. So when I ask for alert message, wait until this actually gives me back something. So wait until alert dialog, the div inside there has some text. And alert dialog itself is blocking. So that was that little block that appeared at the top. So the fact that these things are asynchronous, I can hide and just simply say, okay, wait for it and give it to me when you're ready. And just to prove it works. And so wait for is good for arbitrarily inside a test if I want to do this. Now, after I log in successfully, I have to wait a little bit, and then I want to be at the login success page. So any and all clauses that I can put in a then block or any assertion, I can just move into a wait for to then make use of these spin asserts. So there's my test, there's my spinner, there's my message, saw it coming up, and it went through all that. So that's it's a unfortunate fact of life that when you deal with asynchronicity, things get much more complex, but until somebody solves the halting problem, that's what we're stuck with, unfortunately. A quick word on modules. So far we've been dealing with pages, so really representing the thing that the browser is pointing to at that point in time. Modules give us a way to model a particular fragment in the page. The same content DSL, same way of naming and defining content, and then I can go and pull it in to a particular page as needed. So say cart info on this page is that cart info module, and I can reuse that across different pages. So now if I go to the home page, I can do cart info.totalCost, which ends up being cart info total cost. And of course I can then reuse that cart info module across different pages as well. Geb supports page inheritance and module inheritance as well, but this is more of a mix-in kind of approach. So if you had, say, a constant footer across all your pages, it might make sense to have a base page that everything inherits from, then it will inherit that content definition. But if you have to sprinkle reusable content across different pages, modules are good for that as well. Okay, so just a quick wrap up on a few other features. So one thing I did forget to show, which is very important, is that Geb has inbuilt reporting. This is something that if you ever use WebDriver, I'm sure you've built yourself. So some way to know when things go wrong, how do I get some information other than my exceptions? So all I need to do is extend Geb reporting spec instead of Geb spec, and I get, at the end of each method, a HTML dump of the DOM state at that particular time. So it's not the HTML that was necessarily returned by the server, and we might be able to see that by what's going on here. Here's my form fading in. So it's actually the state of the browser at that particular point in time. So after the JavaScript is run, all that stuff, so I can get to see it, and I get a nice screenshot as well. So just by extending Geb reporting spec and saying where should those reports actually go, I get that for free. And if you're wondering, I can easily say that by just putting a Geb config file on the root of my test tree and specifying something or where they should go. There's a bunch of different ways to configure Geb and tell it what to do in certain circumstances. Reports there is one thing that I need when reporting. Here's my base URL for resolving relative URLs against as well. So that's a nice little framework for just decoupling that information out of your tests. Yeah.
Okay, obviously we couldn't show you all of the cool features of Geb, so let me just quickly run you through some of the more advanced Geb features. So a question that comes up often is, can you also test mobile applications with Geb? And the good answer is that WebDriver, the underlying workhorse, supports both Android browsers and iPhone and iPad, mobile Safari. And you can run the tests on the real devices, or you can run them on the simulators. And Geb just uses that. Whatever works with WebDriver works with Geb. So there is a solution to that problem. Another question that often comes up is, what about single-page apps? We don't have these traditional web apps anymore. We often have single-page apps. And if you only have a single page, what do you do with the page object pattern? Does it still make any sense? And the answer to that is there is no real difference. Even if technically it's a single-page app, logically it's still composed of many pages or screens, and you can model those with the page object pattern just as well. The one big challenge with single-page apps is that they're completely async. So that's definitely a challenge, but Luke already showed you some techniques on how you can test async applications. Some more advanced features, Geb provides a way to interact with JavaScript directly. So let's say you have a script block with a global variable and some global JavaScript function. In the case that you really need to, you can interact with those variables and functions directly. Means from your Geb spec, you have this JS property there, and via that you can read global variables, you can write global variables, and you can even invoke JavaScript functions. So you have a single remote method invocation interface there. Of course, you should use that with care, because functional web testing is about testing the real app, so simulating the real user, and the real user probably wouldn't interact with your JavaScript directly, typically. But sometimes it can be hard to automate a test, and so it's a good fallback if you run into some problems. Another thing, Geb provides direct access to the jQuery object. Another thing to use carefully, but if you need to, you can trigger some jQuery events right from your Geb test. And that's good for simulating advanced user events. So another good trick to have if you want to do advanced things. And there's another way to have advanced interactions, and that's based on WebDriver. So here we have a page class with a div, and now we want to click and hold the div, drag it to somewhere else, while we keep the shift key pressed, and finally release the mouse button. This kind of advanced mouse interaction. And Geb provides the interact block, and under the hood, that's using the WebDriver APIs to do this advanced interaction with your web page. The advantage of that is that these are the real operating system events. These aren't simulated events. So if you need some advanced interaction, you should first use that interaction DSL, and only if there's something that you can't do using that, then consider using the jQuery way. So a really nice way for advanced key interaction, mouse interaction, and so on.
So one of the things that Selenium also supports is the ability to automate a browser running over here. So I can be running my tests on my Mac, and I can be automating Internet Explorer running somewhere else. That's a key feature of Selenium, or WebDriver, and Geb can do anything that it can do because it builds on top of it. So if you haven't looked at that capability, I definitely recommend having a look at it. You can set up a grid of browsers running different combinations. You can connect your Android and iPhone devices to that grid and just pull the browsers together from those different devices and run your tests across them. So that's what's commonly known as Selenium Server or Selenium Grid. There are a few different companies offering this service in the cloud. The kind of market leader at this point is Source Labs. So they provide a grid of machines that you can use across the internet. Basically, you just configure your Geb or WebDriver to just point to that and run it. The thing that Geb provides is it provides some tooling integrated with the Gradle build tool to manage this whole aspect. So from my build, I can run my tests. In my build, I define these are the sets of browsers that I want to use. Don't have time to run it, unfortunately, but I can just quickly show you what it looks like. So in my Gradle build file here, I'm using the Geb Source Labs Gradle plugin. I say I want to test with these 3 browsers. I have some configuration here. This is my username and password for Source Labs. I can run this. It will just throw my tests up at Source Labs server. It will open up a closed SSH tunnel between my machine and Source Labs, so I don't have to expose my application to the public internet. It will just take care of all that stuff for me and make it a lot simpler. There's some IDE integration and other things as well there. So definitely worth checking out as well.
Okay, let's do a quick wrap up. We've talked about Spock, the developer testing framework for Java and Groovy applications. If you want to learn more about Spock, the homepage is spockframework.org. We're currently writing on a whole new reference documentation. Source code is up on GitHub. And of course, we have a user mailing list, so drop us a note. And all Spock artifacts are available from Maven Central. Then we've talked about Geb, the Groovy browser automation framework. Homepage is www.gebish.org. It has a great reference documentation. It has a great manual, goes into lots of depth. So I definitely recommend you to check that out. Also hosted on GitHub, also has a mailing list, and of course also publishes everything to Maven Central. We do have time left for 1 or 2 questions. Any questions, anyone?
Yes. Yeah, sure. So you can do that as well. Yeah.
So what was the question? Can you repeat?
Oh, sorry. The question was, can you integrate Geb and Cucumber? The answer is yeah, absolutely. So just in your step definitions, instead of using the straight WebDriver API, you can use Geb. And there's actually some built-in support you can use to make the DSL if you're using or Groovy in your step definitions to make that a little bit easier. But it is using Geb from Java or another language is quite tricky. Really is designed to be used with Groovy, but absolutely can be used with Cucumber.
Any other questions?
Yes, at the back. So can you use wait for with the JavaScript interface? Yeah, absolutely. And this is so the question was, can I use wait for in the JavaScript interface? So I need to wait for some kind of JavaScript state to be true. And that's absolutely, you can do that. So just be wait for inside the curly brackets js.myvar equals whatever. And that's a very common, sometimes you get into these problems where you have lots of asynchronicity and detecting state changes is difficult. So you put something in there, so I'm going to set some flag when something changes, then your functional test code, the only way to see that's happened is to look at that flag. So yes, those features combine without any problem.
Maybe one last question?
Yes? Sorry, can you please repeat? Okay, so I think the question is, when the test is finished, how would you collect the testing report? There are a few ways. So Geb will just dump it out onto the file system where you tell it to, and it's going to do that at the end of each test method. So you can sort of do what you need to do with that. If you're interested in integrating that into your CI server, which I think is what the question might be about, like I want to get my screenshots and my HTML on my Jenkins server, is that what you're asking? Not quite? Okay, if anybody does want to do that, definitely check out the JUnit attachments plugin available for Jenkins. It allows you to associate arbitrary files with your test execution. So in my test fail page, I can see the screenshot of what it looked like. And that's explained in the Geb manual, if that sounds interesting to you.
Okay, so thanks a lot for attending. We hope you'll give Spock and Geb a try. If you do, drop us a note on the mailing list. And with that, thanks, and have a great remaining conference.
Thank you.